people not here. All right, guys and girls, our objective today is to start chapter 12. So just a little overview of chapter 12. I'm going to do most of it with you. Some of it I am not going to get into as much detail as the book does because this is an Algebra 2 chapter, really. Like I told you before, I've never gotten to this chapter in Algebra 1. So it's applying rational equations and functions. So we'll learn more about graphing. We're going to learn more in particular about 3 of the functions. More so today, the inverse function. Okay, I'm going to show you what that's called. We'll graph some on the calculator. We'll graph some by hand. When we get to the simplifying rational function part, factoring comes back. So you'll see what this is really used for. Okay, I'd like to try to get through 12.1 today. I'm not doing every single problem in the notes. This is the first time I made this packet, so there's probably too much in there. So just bear with me here because I'm going to skip through some of it. Some of this you already know, which is kind of nice. And I didn't realize that until I looked through this about 2 months ago. So 12.1a, we're going to solve direct variation problems. I mentioned this to you once or twice before. Does anyone remember what direct variation is? Yeah, and if not, that's okay. Okay, all right. So direct variation, just a summary, is when a graph goes through the origin. That's it. Okay. All right, so that's why it's pretty easy. Okay, first definition, and feel free to jot down what you need to. Constant is a quantity that does not change. Surprise, surprise, right? Constant is a quantity that does not change. There's something called a variation constant, such as y equals 2x. So you guys know when you graph that, you would start at the origin, you go up 2 over 1, up 2 over 1. Your variation constant could also be called the slope with direct variation. And here we go. Variation constant, a non-zero quantity that will not change within variation equations. So of course that is not going to change. There's not one. Well, I should say that. There is one. A constant could be categorized as anything, Gigi. Like if I have, for combining like terms, we have 2x squared plus x plus 3 plus 1. The constants are 3 and 1. A variation constant, yes, is in a variation problem. The 2 is the variation constant, which you can still call your slope. Okay? And the book uses k for the notation of variation constant. And I'll show you that here in a minute. Oh, here it is. Okay, direct variation. The most important thing here is this equation. You can write down whatever you need to, though. Okay, so here's what the book says. 2 variables, y and x, are related by an equation. The equation that they are related by is, with the one I circled, y equals kx. K is the variation constant. Since k is the variation constant, its value will remain the same non-zero number. What happens if k is 0? What would the graph look like? Luke B? Good, it's going this way. If k is 0, you'd have y equals 0. It'd be a horizontal line. There's, of course, no slope. So it'd be going this way. Remember, if y equals a number this way, k equals a number is always this way. Okay? So nothing completely new yet. The notation's a little bit weird here because the book and the Algebra 2 book uses k for the variation constant. Yeah, you can. Yep, I said that. All right, now this is something I added in from your book. There are 3 types of direct variation and characteristics. So there's some things you need to fill in. The first one is direct variation. So the equation is y equals kx. K is the variation constant. The value does not change. Keywords, you'll see varies directly. So keywords, you'll see usually y varies directly with x is what you'll see. But I just put on there varies directly because they could have some different things added before and after. But basically, varies directly. And I'll show you, hopefully, a word problem with that today, so you'll see what I mean. Second one, of course I'm going to make it harder for you guys. Direct variation with the square. What kind of graph is that? A quadratic, so it's a parabola. So it's a direct variation with the square because the parabola goes through what? Goes through the origin. Good job. All direct variation, if you haven't figured it out yet, goes through the origin. So the first one we have was linear. The second one is quadratic. But the Algebra 2 book calls it, and your book, direct variation with the square. Same thing here. K is the variation constant. Its value is not going to change. Keywords, varies directly with the square. So let me just draw a picture real quick. This one will be linear. That one's a parabola. And yes, it could be this way or upside down. Eric, what do you think the third one is? Good. What do you think it's called? Direct variation with the cube. Good job. See how smart you guys are? I just moved it down now. Oh, man, that's right. All right, Luke C. Luke C. You're going to be up here with me in a second. Quit arguing.
Yes, Luke.
Okay, direct variation with the cube. Y equals kx cubed. K is the variation constant. It doesn't change. Keywords, varies directly with the cube. What does this graph look like? Do you guys remember? Luke B, come up and draw it for us. No, down here. Pretty close. Yeah. No, you're good. How you should try to do it a little more flowy. You're fine though. You're fine. You're fine. It's like a squiggly line. Is this one positive or negative? Positive. Hold on. The negative goes down from left to right. Will? The what? Oh, thanks, Will. Didn't mean to erase our parabola. Nathan. Yeah, give me 1 second. So, one more time. The similarity to all three of these is that they all go through the origin. Okay? You have a linear, quadratic, cubic. These are three types of functions. These are always functions. You guys got that? All right, Nathan, you need this? Okay. If you guys are good, flip over your notes to page 3 and just wait for me for a second. Good. You finished? Okay, thank you. Wow. How'd the interview go? I got LASIK eye surgery. Am I okay? Yeah. Sorry. I should have told you guys. Mom, keep me posted. You know what's funny? Some teachers don't know I got this done. So I'm like, are you okay? Are you crying? My eyes look a wreck. Nathan, are you done? Maybe I should say that. I should make that up. Hey. Be nice. Be nice. That's, Nathan, are you okay? Because that thing was breaking. All right, next page. Guys, we're going to be back to regular seats here in a minute. Okay, direct variation. I want you to write down the equation. Y equals kx and positive. So y equals kx. And yes, k is still the slope, which the book calls the variation constant, but we're going to keep it as k. Y equals negative kx, decreasing. Direct variation always goes through the origin. Direct variation with the square. Y equals kx squared is the positive one. We just went over this. So draw your positive parabola. The negative one, y equals negative kx squared. Make an upside down parabola. And then direct variation with the cube, y equals kx cubed. Positive one is like Luke B drew, but make sure it's a little bit more spread out there. Bless you. And then, no, Luke, you did a good job. y equals negative kx cubed is a cubic function, but it's decreasing from left to right. So 3 types of functions. We're going to look more closely at each of these today. Okay, is everyone done with those? Okay, here's where I'm going to start to skip around. Okay, example 1, the directions are identify the following equations, and then your homework has this on, as direct variation with the square, I thought that was wrong, or direct variation with the cube. And then identify the variation constant. So letter A, what kind of direct variation is that? Luke B? Good. So I'm going to write down dv, direct variation with square. I'm going to abbreviate. Direct variation, sure, with the square. Just know what that is, Luke B. Jared, what's the variation constant on letter A? What's the variation constant? Good, 7. Okay, the second one. Eric, what kind of direct variation is that? Good. So I'm going to put dv for direct variation with the square. Kyle, what's the direct variation constant on letter B? Good, 1/2. Letter C, Kevin, what kind of direct variation is this? Good, direct variation with the cube. Now be careful here. What is the variation constant? Don't yell it out. Raise your hand if you know. Andy? Awesome. How'd you get that? Good job. To make sure it's in y equals form, remember, direct variation, the standard equation for cube is y equals kx cubed. Make sure it's always in y equals form. Kevin and Luke B. Stop. Okay, letter D. Brian V. What kind of direct variation is this? Good. Just regular direct variation because the exponent or power is to the first. Marissa, what's the variation constant? Good, 1. Okay, letter E. Brianna, what kind of direct variation is that? Good, just regular direct variation. Take a minute, put that into y equals form if you haven't already. And once you get the direct variation constant, put your hand up. Eric? Good. K equals -4/7. Okay, letter F, Gigi, what kind of direct variation is that? Good. With the cube? And good, Gigi, what's the variation constant? Good. Yeah, I would just leave it as 9 pi. You're more than welcome to multiply 9 times 3.14, but you don't need to. Okay, I just realized I want to add in a problem. You don't need to write it down, just watch. What kind of direct variation is that? Well, good. Why is it not direct variation? Good. So your homework has some questions. It asks you, Luke B. It asks you what kind of direct variation things are. If it doesn't go through the origin, it's not direct variation. I know it does not take a genius to figure that out, but don't let them confuse you. Okay, flip over to example 2. Okay, so we need to identify the variation constant and then solve for y when x is 6. Let's just do one of these. So letter A, Nathan, what is the variation constant? 2. Good. Will, if x is 6, what is y? Good job. So I'm not going to do any more of those. Just like we did, identify k. Don't worry about saying what kind of direct variation it is, and then they're asking you to evaluate. So we're not going to worry about that. Let's go to example 3. Will, what's up? Good. Yeah, that's still direct variation of the square. Because as long as it goes through the origin, you're fine. Yeah, good question. Very good question. All right, let's go to example 3, not 4. I didn't mean to do that. Okay, example 3. For each of the following problems, we need to identify the variation constant again, but now find x when y is something. So let's just do one of these. Marissa, what's k in letter A? Good. 2 pi is the variation constant. And now all we need to do here is find x when y is 12. So we have 12 equals 2 pi x squared. What should we do first on a problem like this to solve for x? You'll see problems like these in geometry. Nathan, what do you think? Not subtract. Be careful. It's 2 times pi times x squared. Divide both sides by 2 pi. Now, what I'm going to have you do is, if you didn't already, on your calculator, multiply 2 times 3.14, and then do 12 divided by that answer, and tell me what you get. So you're essentially doing 12 divided by 2 pi. You can use the pi button or 3.14. Nathan, what'd you get? Good. So x squared is 1.91. How do we get rid of the square? Luke B? Good. So square root both sides. Luke C, what is x? Are you with me or did I lose you? Okay. Good. 1.38 about. So if you end up with pi in something, go ahead and change your denominator or numerator, whatever it may be, to a decimal, and then make sure you square root both sides. Okay, I want you guys to try B and C on example 3. Luke B, what do you need? No, just this page. Okay, try B and C. When you're done, put your pencil down so I know that you're done. Find K and then solve for X. B is pretty easy. C is a little bit confusing. Yeah, I told you that. Yeah. Make sure you're following me, okay? Oh, no, I didn't do this one. Sorry. That's just that one. Never mind. All right, letter B. Brianna, what did you get for K? K first. 4, and then you got X is 3, right? Okay, good. Eric, what did you get for K for letter C? Good. 6/7 pi. And X in this one as a decimal. Does anyone think they got it? No one? Kyle, what do you think? Say that again? Nope. Unless I messed up. Brianna? Nope. Anyone else? Want to take a guess? Okay, so let's do this then. Yeah, if y is 12, we have 12 equals 6/7 pi x cubed. So the first thing you need to do is divide both sides by 6/7 pi. What I would do is multiply 6/7 times pi first, and then do 12 divided by that. So tell me what that decimal is first. Gigi? That's fine. That's fine. Yeah, what did you get for your decimal? Tell me what you got. What did you get for your decimal? When you divided, did you get 4 point something? 4 point what? Okay, do that again. When you guys, after you do that, Eric, what'd you get? Yeah. So you should get x cubed. Gigi, make sure you got this, because I think that your way is perfectly fine. It's actually probably easier that way. X cubed equals 4.46. And there's, as Gigi said, you could multiply both sides by 7 first, and then divide by 6 pi, or multiply 6/7 times pi, and then do 12 divided by that. On your calculator, under math, there's a cube root button. Are you guys aware of that?
Yeah.
Okay, Luke B, relax. Luke, seriously. So I'll say that again. If I may have mentioned it last year, not this year, but under math, there's a cube root button. So if you click on, what number is it? 4, is it 4? So whatever number it is, click on it. And then if you type in 4.46, it cube roots the answer here, or the number on the right, I should say. When you cube root it, what is the answer? Nathan? Good. So the answer here, did anyone get that and you just didn't tell me? Good job. So 1.65. That's okay. I don't know. Gigi, your way worked. You got that right? Okay. Yep. Perfect. And then cube root it. Any questions on that one? All right. Example 4. So a little bit different here. We now know what x and y are, but we need to find k. So it says here, for the following, assume that y varies directly with the square. So you guys need to write down y equals kx squared, because we know it varies directly with the square. We know k is the variation constant. We know x and y in this problem. We need to find k. So let's plug in what we have. We have y is 1.35, and x is 5. So at this point, we need to solve. What did I do here? Okay. So let's square 5 first. So we have 1.35 equals 5 squared is 25, so 25k. So to find k, divide both sides by 25. What is k? Gigi. Good. K is 0.054. Can someone convert that to a fraction for me? Gigi? Awesome. 27 over 500. All right, so if I were to ask you one more step, write that into the direct variation with a square equation. So if you write that into the equation, what's our equation? Gigi? Yep. Yep. Good. So I'm just going to put it like this. Now, Gigi said the numbers, which is fine, but to keep it simpler, keep it as y and x. So if we had to graph this, we found the slope. Basically is what we did. Anyone know why would that work? Why is that the exact same thing as the slope formula? Look what we just did. Jared, why does that work? Okay, but why is that the same thing as the slope formula? Anyone? Can anyone take that a step further? Okay, so we have an ordered pair up there, right? We have 5, 1.35. What's the other ordered pair that we always have with direct variation? Luke B? No. Brianna? Good. 0, 0. So if we always have the origin, you can always just do y divided by x, because y minus 0 is just that number. 5 minus 0 is just 5. So it's always just, which was what we did right here, y divided by x is always going to give you the variation constant. Did anyone else realize that? Okay. The book does not teach it the way I just said. They have you plug it into the equation. But I prefer, when I do this without teaching it, to just do y divided by x. Okay, let's do another one of these together. Let's do letter C. So we have y is 189, x is 3. Go ahead and find slope, which is the variation constant. It varies directly with the square, so be careful. And obviously make sure you square it first. That's what you need to be careful of. Luke, did you get it already? Okay. Did you get it? 1 second. All right, Gigi, what'd you get? Did you do, oh, you did B. That's right for B. B is, if you guys did B by accident, K is 5/3. That's okay. K is 5/3, which is 1.6 repeating. But C, sorry, you guys might, maybe I said it wrong. Kevin, what'd you get for C? Okay. C is 21. You end up with 189 divided by 9 because it varies directly with the square. So if it varies directly with the cube, what's the only thing that would change up here? Cube it. Well, cube it. Cube it. Eric, question? Oh, yeah, go ahead. Yes. Good. Y equals 21x squared would be the equation for our parabola, which is direct variation with the square. Okay, let's do one word problem. Flip over. Yeah, we're just doing one. It's not hard, I promise. Okay, last problem, okay? Let's do number 3. Okay, number 3. Shh, relax. Okay, the volume of a sphere varies directly with the cube of the radius when the variation constant is 4/3 pi. So, ready? Hold on. The variation constant is English. We'll start with that. Variation constant is 4/3 pi. I'm gonna baby this for you. So let me read it again. The volume of a sphere varies directly with the cube of the radius when the variation constant is 4/3 pi. So someone fill in for me. Either you remember the volume formula for a sphere from last year, or you translate this into an equation. Gigi. Yes, that's all I want. Let's keep it like this for now. That's okay. One more thing. Or what, Brianna? Awesome. Look, guys, with the cube of the radius, you guys are smart. Cube, you guys just don't like word problems. Cube of the radius. Okay, that's the equation. That's all you need for part A. No, we're not going to stop. Okay. Letter B. What is the volume of the sphere when the radius is 11? So really easy. Volume equals 4/3 pi 11 cubed. All right, you're going to solve that one. Here's what I would do. Order of operations from when I had you guys in September 2 years ago. Cube the 11 first, and then multiply by 3.14, and then multiply by 4/3, which, yes, you could change to 1.3 repeating. You will get a decimal answer. Yeah, and it is a big number. When you get it, put your hand up. Well, a year and a half ago then. Thank you, though. A little more than a year and a half ago. A year and 3/4 ago. Did you get it, Alina? Okay. Jared, are you doing it with him or helping him? Okay. Hi. All right, Alina, let's try. What'd you get? Awesome. All right, Alina got it. So check. Hey guys, listen. 5,572.5 inches squared. So let me go through it step by step. Okay, so first thing I did was square 11. Brian C, stop. Or cube. 11 cubed is 1,331. Multiply that by 3.14. And then multiply that by 4/3. So that's all you need to do, and you get 5,572.5. Well, if we multiply it by the regular pi button. Yeah, if you multiply by the regular pi button, it's going to be different. That's okay. Yeah, that's okay. So if you use the pi button and it's a little different, that's okay. All right, let's do C together, and then we're done. No, I said this is the last problem. Okay. If the bell rings and we're not done, we're staying here. If the volume is 78.5, we need to find radius. So 78.5 equals 4/3 pi r cubed. So here's what I did. I want you guys to take 4/3 times 3.14, and I did this all in one step. And whatever decimal you get, you're going to take 78.5 divided by that. So can you guys tell me what's 4/3 times pi times 3.14? Gigi? Okay. So the next thing we need to do is divide both sides by 4.18. And you guys should get 18.75. Now, how do you get rid of the cube? Luke B. Good. Cube root both sides. Yep. Something new today. So what is the radius? Don't forget, it's under math. It's like number 4. There's a cube root button. Nathan? 2.66. Good. 2.66 yards. Okay, is everyone okay? Don't move. Open up your homework packet. Well, not this, but there will be extra credit. Hold on, there's not a lot. All right, that's all. Hey, quit complaining, I'm going to add on word problems. Yeah, that's enough. Okay, so just 1 to 9, 19 to 27. Guys, tomorrow, if you don't get quieter, you're all going back to your regular seats, okay? So that's all. Will. Hold on one second.